We've looked at how money can grow when it's not gaining any interest. It's just making deposits. That's not really common. What's more common is to do something like an annuity. And what an annuity is investments made at regular intervals earning interest. And you might be familiar with the equation PE to the RT, which models the continuous growth of an investment. Now, if we're making regular deposits, we need to add up all those regular deposits from 0 to the end of the time of the investment and integrate it with respect to t to get that future value or amount. So kind of labeling everything. A is the future value. P is the regular payment that you're making. R is equal to the interest rate, but we might have to divide into the payments. What I mean is if we've got an annual interest rate, but monthly payments, we would need to divide the annual rate by 12 to get the monthly rate. So you want to make sure the units match with that rate. And then capital T is the time or the total number of payments over time. So, for example, let's say that somebody wanted to invest in a retirement account, and they invested $150 per month at 9% interest for 35 years. Well, the investments are being put in per month, and the interest is usually assumed to be per year. You're probably not going to get 9% per month on an investment, but you could get 9% per year. So we need to change that 0.9% or 0.09 into a monthly rate by dividing by 12. And when I do, I get 0.0075. So that's going to be my rate. The other thing I have to check is the total time. Yes, there's 35 years, but we're doing 12 payments per year. So we actually want time to be in units of months. So we'll do 35 times 12 to get 420 months as the total time of this investment. So with that in mind, all we have to do to get the future value of this investment is integrate from 0 to the end of those 420 months. The payment, which is going to be $150, times e to my rate, which is 0.0075, times my time, dt. And this is an integral we know how to solve. We can solve it with u substitution, where u is equal to 0.0075 t. du then is going to be 0.0075 dt, which means I need to multiply by 0.0075 and divide by 0.0075. I'm also going to pull that 150 out. And so when I do, the future amount is 150 divided by 0.0075 times e to the u, but u is 0.0075t. And we're going to evaluate that from 0 to 420 months. So just plugging those values in, we get 150 over 0.0075 times e to the 0.0075 times 420. And we subtract 150 divided by 0.0075, e to the 0.0075 times 0. And when I put all of that into my calculator, we end up with our total amount with the interest in the account after 35 years. It's going to be $446,721.29. Now, where this gets kind of interesting is if you think about how much money you put away. We put away money for 420 months, $150 each time, which means we invested $150 for 420 months. 150 times 420 is $63,000. Which means I invested $63,000 but ended up with almost $500,000 in the account. And that's really the power of this compound interest. If your interest can earn over a long period of time, you should see significant growth on those annuities, on those investments. With the annuities, we were making regular investments at every month or every week or every year. But usually with a business, money doesn't come in clumps at the end of the month. Money comes in continuously throughout the month. And that's the topic of our next video.